Thanks so much, Kirk. And as Kirk mentioned, extremely excited for this month's Innovation Forum meeting and really excited to have Zeeshan Zia of Retrocausal with us, or I should say back with us, because he actually spoke on the Innovation Forum exactly 2 years ago in April of 2023. Obviously, 2 years nowadays is a lifetime when we talk about innovation. So really excited to hear what's new and exciting that's going on at Retrocausal, as well as what Zeeshan really envisions and can hopefully forecast and give us a glimpse at his crystal ball into what's in store for the future as it relates to innovation. So without any further ado, I will hand it over to Zeeshan to jump into the content.
Thank you so much for the opportunity. It's an absolute pleasure. We are a part of camps. We've been a part of camps for the last, I want to say, 4 or 5 years at this point, and I've had a chance to interact with a lot of camps members, and of course get to interact with also the technical talent in the greater Seattle and the Washington area, and have constantly been inspired with both the manufacturing capacity and capability as well as the technological capability as it pertains to manufacturing technology. A little bit about myself. I did my graduate studies in AI, was an AI researcher for about 12 years. My last job was at Microsoft in the HoloLens division. HoloLens was this augmented reality goggles that you put on your head, and it's supposed to help assembly line workers and beyond with training and so on. So that was my last job, and I started the company Retrocausal right after leaving Microsoft. That was exactly 6 years ago at this point in time. Causal, we are building what we call the AI Production Supervisor. And AI Production Supervisor means so the job of a production supervisor, especially in discrete manufacturing, is threefold. Production supervisors are responsible for quality, as in making sure machines and human associates are doing the right job. They're not making too many mistakes, and making sure that first time yields stay low, stay high. So quality is one priority for production supervisors or line leaders. Then they care about productivity. They want to make sure that more at a broader level, your lead times stay as little as possible, your throughput stays as high as possible. And then finally, whether it is around making sure your cells are highly optimized, whether your interdepartmental transportation is highly optimized, whether if you have assembly lines, they are highly optimized. So that's the productivity piece. And then safety as well. You want to make sure that accidents are not occurring in your workplace, and operators themselves are comfortable as they're doing their job, which in turn means better employee loyalty, which in turn means being higher productivity and higher quality as well. So we are building that AI production supervisor at the moment, and these productivity, quality, and safety aspects are represented in 3 different apps that we have shipped, and I'll talk about those apps in a bit. Assembly Copilot, Kaizen Copilot, and Ergo Copilot, respectively, for quality, productivity, and safety. Right now, our customers are pretty big enterprise manufacturers. We have 3M is we are deployed across 15 factories of 3M. 3M is the world leader in filters and industrial adhesives. We are at multiple factories with Carrier. Carrier is the world's #1 HVAC systems manufacturer. We are with multiple factories of Boston Scientific and Stryker. They are top 10 auto med device manufacturers, and so on and so forth. We are with Schneider Electric. We are with Stellantis at their Jeep facilities. We are with a couple of others. These are all, at the moment, mostly high volume manufacturers, high volume, low mix manufacturers. So I'll show what we've been doing with them, or I'll show the products that we have and how they help those kinds of manufacturers as of today. But we're also beginning to look more and more into mid-market manufacturing, which is more and more high mix, low volume kind of manufacturing. And there are certain thoughts that I have in that direction, certain tools that we are building there as well. I don't have much to show at the moment, but I wanted to take this opportunity to invite camps members. If you have specific challenge, once you hear what we've built out, if you have challenges that sort of relate to productivity, quality, and safety, where you think AI might be there to help, might be able to help, we are actively working on bringing in a lot of those problems and trying to solve those problems in our products as well, so that you can solve some of the stuff that you encounter. The fact of the matter is, at the end of the day, Toyota production systems or lean manufacturing, a lot of those concepts, they are great for high volume manufacturing, but they're not that great. They're not the perfect fit when it comes to job shops. And that's something that we are really cognizant of. And we've been thinking about a lot of those problems a lot. And I'll share some thoughts on that in that direction as well. And would love to get your input in that direction also. So again, in summary, what I'll talk about is I'll start out by talking about the problems that we tackle for high volume manufacturers today. I'll give you a brief overview of the top of the software that we've built out, the kinds of capabilities that are there. We have a lot of granted patents. I was just talking to my co-founder, OpenAI, which is the world's leading AI company. They have a couple of patents that came out last week, and they are citing a lot of our patents, right? So basically, we are doing a lot of stuff that AI is building on top of, or they are acknowledging that this is really state of the art stuff. So I want to show you some of that stuff, and then I'll talk about, again, please, I would love to keep this conversational instead of just being a presentation. So please feel free to stop me in the middle, ask questions, or have your comments, have discussion. And then I'll share some thoughts on what we are thinking, how we are thinking about job shop, applying lean to job shops, and how software can help in that direction. And then have an open invitation if you have specific problems that you think could be solved in your businesses that pertain to what if you had a virtual production supervisor or a virtual line leader who could do a lot of these things. We'd love to basically incorporate a lot of those. We'd love to partner with you and try to build a lot of those capabilities within the software. Okay. Any thoughts, any questions, anything, please feel free to, yeah, comment. And I'm going to share my screen at this point, and otherwise I can start with a couple of slides and then jump into the actual software and the actual tooling that we've built. Okay. So we are Retrocausal. By the way, we are headquartered in Redmond, Washington. So we are pretty close to you, to all of you. We also have a satellite office in Dallas, Texas, and another one in Minneapolis, Minnesota, where we have a bunch of team members working out of as well. But we have the bulk of our team based out of here in Seattle, Washington, in Redmond, Washington, and we have basically grown 3 to 4x just over the course of last year. And so the challenges we are tackling are around labor shortages, but also around it's really hard to find trained workers. It's hard to find trained engineers, especially in the industrial and manufacturing engineering space. Call them continuous improvement supervisors, call them operational excellence managers, what have you. And because you have shortages of this talent, manufacturers, even high volume manufacturers, are having to resort to relatively less trained or misqualified workforce. They're having to work with often temporary workers who, they the turnaround of a lot. We are working with an automotive factory, and the turnaround there is 176% a year. Turnover there is 176% a year, which means that almost as many people leave the job as there are on the factory, and then 75% more every single year. So it's really hard. They're basically onboarding 100 people every single month. So it's hard to train these operators, and then obviously they tend to make more mistakes that result in quality challenges. And then a lot of tasks where you could really use a formally trained industrial engineer or a manufacturing engineer. Those tasks are being performed by folks who are doing things with their intuition. How are you going to design cells? How are you going to design lines? There, a lot of people are not able to benefit from industrial engineering knowledge, Lean, Six Sigma, and so on and so forth. And inevitably, that leads to loss of revenue and poor quality and waste for these big manufacturers. But then there is this other challenge as well, which is even bigger, which is creating even greater urgency for our customers, which is long lead times, low throughput. Last year, even in that category of Fortune 500 manufacturers, 50% of them had delayed delivery of products, right? So product delays are a reality of life. We primarily play in automotive, medical devices, and HVAC, and in those spaces, 2 to 7 month lead times are the norm. So they're struggling to reduce those lead times as well. And oftentimes their customers, they are basically switching vendors. They're switching their manufacturer just because these manufacturers can't shorten their lead times. And that's something that's creating an urgency for them, that which is why they come to us. Yeah. And then, so essentially what we've done is we have two, now three products. One is Assembly Copilot, Kaizen Copilot, and another is Ergo Copilot. Let me just jump straight into a demo of Assembly Copilot, and you'll see what it is all about. Assembly Copilot is a camera that is observing a station, a job that is being done on a station, and it acts as a digital poker yoke and digital work instruction solution. So essentially, if the operator makes a mistake, or if the operator is not able to follow standard operating instructions, the system offers an alert. Think about industries like med devices, where you have certified with FDA and other bodies that you're going to be following a certain standard operating procedure, but then on your shop floors, the operators are doing something totally different. So you need to make sure that the operators follow, otherwise you could lose your license to be building those products. So I'll start with a demo or two of that. As the operator starts. This is, we've basically presented the same last time as well. This is a video from our offices. So essentially there's a display that is in front of the operator. So this is Assembly Copilot. There's a display in front of the operator that shows the operator work instructions. There's a camera. We are agnostic to the kind of hardware you're using. We just do software. And there is a multimedia projector that's projecting work instructions right on the working surface. So the operator just brings this fan unit into the station. He's supposed to install the fan into the unit. On the right-hand side, he can see the work instructions overlaid on the work surface. I don't know if you saw that, but there was an arrow that was pointing to that where the operator picked up these parts from. He was now supposed to put that bolt and that washer over there, and he didn't. So the AI notices that. The AI is tracking every step of the activity that the operator is performing. And the AI noticed that the operator missed that step to install the washer in the bolt. It's pointing out. And so essentially the operator now goes in. There's a stack light that's going red. A lot of these peripherals that are optional are there as well. But as soon as the operator fixed that mistake, the error message disappeared. So now the operator can move on and continue to do his job. And again, the Assembly Copilot is essentially an extra pair of eyes, trained eyes, that's helping the operator avoid those mistakes and let them do their job. Any thoughts there? Any questions? I have a ton of videos to that effect. We have entire cars rolling down the line with assembly. Slightly older video. Again, there's a display over here that the operator will look at momentarily. There's a stack light over here if the operator makes a mistake. Again, the system is able to track. It's able to interact with their MES system, figure out the steps that need to be performed for the current vehicle that's on the line, because it's a mixed model line in this case. It's not quite high mix, but there are multiple kinds of products that are flowing through the line. And the system is keeping track of whether the operator is actually doing those steps or not. And it can offer an alert in real time. Let's see. I have a bunch of others as well in here. Another automotive example, the operator is doing this. This one is from Japan. The operator is doing a bunch of steps and the system is tracking every step of the activity. And if the operator makes a mistake, the system can offer an alert. By the way, this can also talk to smart tooling. So if you have tools like smart torque drivers, we can read in torque values and We can offer alerts if the right amount of torque is not applied. Similarly, we can actually stop a conveyor belt. We can lock and interlock. It's really a digital mistake proofing system. If the operator has made a mistake, we can help you fix that mistake. So this is another one from our lab. Let's skip that. But then, yeah, please.
Zeeshan, I have a question. So you talked about from a digital work instruction perspective, and then it connects to the MES system. I have a question in terms of how is this actually helping with the compliance reporting, especially from an OSHA labor perspective? And has that been a concern which has been raised by factories?
Could you repeat the earlier part of that, RC? I guess that's, sorry, I have some audio issues maybe.
Oh, no worries. I asked the question, how is the information which you are tracking from AI being used for compliance reporting, especially in terms of labor or OSHA kind of requirements?
Makes sense.
And how is that being viewed by the factories, the supervisors, labor workforce, etc.?
Yeah, makes sense. The OSHA piece, I'll come to that. We are not doing monitoring for OSHA compliance. In fact, typically the 90% of the cases, we'll mount the camera in such a way that it cannot look at the operator's body. It can look at their hands, but that's about it. And when it can look at more of their body, so some of these videos are like 2 years old. This is from 2022. I can only share what I have permission to share. By now, we just completely truncate out the whole body of the operator, even if the camera is mounted in a way that it can see the body. So we have a separate product, and I'll talk about that in a second, Ergo Copilot, which you can use to improve your processes from an ergonomics perspective. That's the safety aspect of it. But it's asynchronous. So you'll record some video and then you can upload it and you can get recommendations related to ergonomics, health and safety. But we don't do OSHA related compliance in real time. That's something that operators, line workers often don't really like, or we haven't had a lot of interest in that, at least so far. I'll show you the compliance with respect to sticking with the standard operating procedures, right? Whether the operator is actually complying with the standard operating procedure, especially in a medical device of the sort that you're seeing here, right? This is a gadget that's being built, and this company has committed to FDA that they'll be building it in a certain way. So if the operator is missing some steps, in this case they did, we are showing the operator that alert right there, first of all, in real time, but then there is also a dashboard that I'll talk about in a second. Does that answer your question, RC?
Yes, thank you.
Okay.
Zeeshan, I have a question here.
Of course.
What is the licensing model for this product and what does it cost?
Yeah, licensing model is SaaS based, it's a software as a service, subscription based, basically annual subscription. We charge $800 per seat per month. So $800 per station per month, basically. And setup is included in that, if it makes sense.
Okay, so it's not by user, it's just by seat, by workstation. Right. So if you have 5 of these on a production line, that'll be 5 seats.
That's right.
And in terms of setup, is it your team doing the setup, or would the manufacturer have to basically upload these instructions and videos?
So the manufacturer is typically able to do most of it. We will come in and we will train at the beginning for sure, but certainly we are there to help. If you do need to change it significantly, we have a services team that can help there, and a customer support team as well. But at the beginning, we'll certainly come in, we'll train you to the extent that we will basically do the whole setup more or less for you.
Follow-up question to what Jason was asking. So the number of work procedures, is there a limit to the number of work procedures that you can actually have in a station?
No, there's no limit. So it can be, we've handled processes that are 30 to 45 minutes long. That's the limit that we've seen so far. To set this up, you do need about 100 cycles of the assembly process, right? So if you're really talking about something where it's an 8-hour long process where the operator is just sitting there and building, I don't know, sitting inside an aircraft or inside the fuselage of an aircraft, and they're doing wiring all day, every day, that's probably going to be hard. But in our industries, typically we are addressing a few minute-long processes from anything from 30, 40 seconds to 4 minutes long. So in this case, I don't know if you can still see it on the screen, but we are at about 4.5 minutes at this 4 minutes and 17 seconds at the, so, this, I think this video has just one cycle in it, and this is 10 minutes long. Was that what you were asking about?
Yeah, that was one. And how long does it take for the manufacturer to set up a process?
It's really quick. So again, as soon as you can provide us with 100 cycles, if it's a relatively short cycle time, you are able to do that in a shift. If it's an hour-long process, then you'll probably, at most you can do is maybe capture 10 cycles, 20 cycles, 10, 15 cycles a day. So it might take you several days. But so again, I'll show you the Assembly Copilot dashboard and how you set a lot of, again, this is my demo dashboard, but how you'll set it up is you'll define or we'll help you define the operations. You'll set it up to record training set. The camera is there. You can control it from the cloud, from this portal, and then you'll send a train model request and you'll get it back in a day or so at most, if it's a really complicated model. But really, it's all about how much time does it take for you to record 100 cycles of the process.
Okay, which means that once you have those 100 recordings and you are creating the model, then somebody needs to go in and verify whether the model has been trained correctly and make those adjustments.
Sure. There is again, I can go into those details as well. We do have a zero code programming environment. I'll have to see where I have some of those examples. But we have a zero code programming environment where you can see exactly what it is that the system is tracking and verify it that way. But the system is also able to show you those results over the videos that you've recorded. So you get a sense out of there. And then, yeah, you set it up on your lines and you can immediately see if the system is actually doing what you expect it to do. Customers won't connect a conveyor belt and actually start stopping their lines with the system right out of the gate. Typically, you'll have a monitor and you'll be saying, hey, is it really tracking the activity correctly or not? And you can simulate certain things. You can say, hey, you can talk to the operator and say, can you please skip this step? Or can you do it this way instead of that way? And you can see if the system actually captures that or not. Typically, I have a couple of customer testimonial videos with me where customers have, acknowledged that we are like 99.9% or higher. We have a higher accuracy than that even, if it makes sense. But yeah, you'll probably want to actually see if it actually works or not once you have the model. Yeah.
Thanks. I will ask follow-up questions later. Thank you.
Of course. Okay. Okay. And then this is the dashboard. You go to retrocausal.tech and whatever your organization's name is, if you are 3M, this would be 3m.retrocausal.tech, or if it is whatever Toyota.retrocausal.tech. So what I just showed you are these videos. This is what the operator sees in front of them. It's fairly customizable, which is why you're seeing slight variations of what the operator is going to see, the kind of work instructions that the operator is going to see. But all of that data, the analytics out of that, and then videos of every individual cycle are being sent back into the cloud. Optionally, you can turn it off if you want to, so that you can then go back and do root cause analysis. For instance, here I have some data in my demo account. So I want to see what happened in this time range. We went to a conference and we did a bunch of cycles there, and that's the data that I'm going to show you. So we captured 96 cycles in this time frame from this station, and some of them were good cycles, but a lot of them were bad cycles. Again, in reality, these cycles were recorded at a conference, and we were intentionally making a lot of mistakes. You see the average cycle time has been captured by the system for those cycles. You see the total work time, average value add percentage, TAC percentage. You can see average step duration. So the amount of time that's being spent on each individual step, as well as standard deviation and variation around that time. So Titan top and bottom screws the standard time is 5 seconds, but the standard deviation is way too much in here. And you might want to go in and investigate why that is the case. Similarly, on the right-hand side, you see the cycle time distribution on x-axis. So these are the cycle times. On the y-axis, you see the number of cycles, and you can go in and say, okay, why are some cycles taking as long as they are? And I can click on one of those bars and arrive at this screen where I can just, like YouTube, I can just play back all the videos that have been captured out of that real-time operation. So here's my colleague at the conference center, and he's demoing this particular process to a bunch of people. And you can see what happened exactly there. And I can click on a different step, and it will just take me to that step. You can also add comments, and you can say, okay, John, did you see this bar is not working? Did you see what just happened there? So you can make comments here, and then John is going to get that email. John might be a team member, and so on. But this is how you can do some amount of root cause analysis by going back into those cycles. And then there's a lot of other kinds of analytics in there as well. There are interventions. So how many times did we have to intervene to get the operator to do the right thing? You can see that this kind of gives you a sense for how many mistakes the operator might have done if we hadn't intervened. You can have value add time by session and a bunch of other kinds of data as well. And then we have this, you could just be seeing all of the videos. So essentially like a YouTube of your assembly line. You can see all of the data, every single cycle, and basically, again, browse through those cycles and see what's going on. These cycles can also be correlated to a product serial number. Like in automotive, we'll often do a VIN number. So you'll be able to search something by VIN number. If a product comes back to you, you can see what happened, why it came back to you. You can look at the entire journey of that car or that engine through the line in these videos when you go into line visibility or in the issue center. And then, similarly, setup is really simple. OPC is this universal language that all smart tooling speaks. And you can connect a conveyor belt with the system by just the click of a couple of buttons. Any thoughts there before I move on to? So that was Assembly Copilot. I want to move on to Kaizen Copilot and talk through a little bit of productivity and ergonomics use cases as well.
Zeeshan, if you don't mind, what has been your customers' feedback and experience? Because I'm imagining with metrics like they could see these metrics, but like how many times they had to intervene or things like this, they're seeing real value out of this Assembly Copilot. But what kind of things have they mentioned about it? Have your customers mentioned?
No, absolutely. They love the product. They're expanding rapidly. We had 100% renewals last year, grew sales by 4x last year as well. That's indicative of how things are going. But customers are seeing consistent increase in throughput. First time yields are improving significantly. In med devices, we work with some customers where due to FDA regulations, you're not allowed to rework the product. If the operator made a mistake, it just goes straight into scrap.
Oh, wow.
Specifically, for instance, we are working on this line where they're building these tiny cameras that go into the human body for kidney stone detection. Really tiny devices, and operators are doing soldering parts on there. But it's a $1,200 device, the cost of that device is $1,200 to the manufacturer. And if the operator makes a slight mistake, that $1,200 thing has to be thrown away. And in fact, you have to document that it was thrown away. So with our cameras, we were able to bring that cost down from 30% scrap rates to 3% scrap rates right after deployment. There are other instances where throughput has gone up by as much as 25%. They are finding value in it. They've been able to move headcount away from things as well. For instance, you might have a person at the end of the line that's just checking whether all these steps were correctly performed or not. And now you can put that person on a different line because the system is automatically doing all of those audits for you and maintaining all those records for you. And again, I didn't show it to you, but in Assembly Copilot, you could download every result in Excel format in your custom templates as well, and all of those things. Does that answer what you were
Yes,
trying to
and
get at,
thank you. That was great to hear the results of it. Thank you.
Appreciate it. I know we are running relatively limited in time. Kaizen Copilot is all about productivity and safety. We also have everything that's in Ergo Copilot is also here. So I'll talk about ergonomics in a second as well. But the idea here is that Kaizen Copilot does not require a permanent camera. You can take your smartphone, capture a video of a process, upload that video into, log on to kaizencopilot.com with your login, with your credentials. You go to File Manager and you upload your files. This is a video of a certain process, right? So this is a process. We just mounted a camera with a magnetic mount on this station and recorded a short video of a few cycles, right? That's all you needed to do. And then you go into station design, and now you can do a start with a time study and then start getting improvement related recommendations as well. So here, essentially, we recorded that video. In the video, you have to go in and specify one of those cycles. Where does the cycle start? Where does it end? But that's it. So you define what you were thinking of as a cycle. You click on cycle detection. It will detect the other cycles in the video. With that, it asks you at what granularity you want to study this process. In my case, I said 13. When I'm doing it for the first time, it will show me the expected number of steps as well that the AI expects or thinks are reasonable. But then from that video where 3 cycles have been performed and nothing else was provided, the system is able to break down your video into meaningful steps. All of these step names are generated automatically. It's able to, on the left-hand side, you see the steps that the video has, in each cycle has been broken down into. So I'm clicking on individual steps. The step names have been generated automatically. And then on the top right, you can see what was each cycle, how was each cycle, how was this step in each cycle. And you'll see that there is repeatability. So the system actually figured out how that step looked like across cycles. So the first thing you get out of this is imagine you are an industrial engineer and you are trying to capture 20 cycles and each cycle has 20 steps. So that's 20 cycles times 20 steps is 400 steps. Traditionally, you would have a templated Excel. You would upload that video into that templated Excel, and then you would manually label each cycle, move a slider to the left, slightly to the right. This is where the step starts. This is where the step ends. To label 400 cycles manually typically takes you 6 to 8 hours. So to conduct a proper time study takes you 6 to 8 hours. Or maybe you're standing in front, right next to the operator with a stopwatch, and by the time you're done labeling the previous step, the operator is already 3 steps down the road. So you are getting pretty weird kind of time studies. But in this case, you get the time study right out of the gate. The system also makes an assessment on whether each step is value added, non-value add, or not necessary but non-value add. You can always disagree with the system's assessments. You can say, no, I think this is a relatively long steps. Yes, there are certain non-value added components in here as well, but I would deem it as value add. Am I still online? We have some internet issues. Okay, seems like I am. I'm having some internet issues today. And then you get your time study out of this. You can download it in a variety of Excel sheet formats. You can download a work instruction template as well. You can compare different kinds of cycles, morning shift versus night shift, part number A versus part number B, and so on and so forth. But then more importantly, you can get suggestions on how you can improve this process, right? So without having to hire a $100,000 industrial engineer, you can start getting some kinds of recommendations on what you might do to improve this process. So here the operator was going to this tote and picking up this part and bringing it back to the fixture, and the system is suggesting you to shorten distances for advantage. That can save you 0.72 seconds every cycle. Again, I understand that for a job shop, that's maybe not much of much value, but these kinds of improvements add up really quickly. It's also, you get a bunch of, in the text format, you can do this, you can do that, improvement recommendations. And then you can also see, okay, this is my bench top, A, B, C, D, E, F, G, H, I, J, K, and L. The AI has broken down my bench top into these regions. This is the amount of time that's being spent in each of these regions. And that zone 4 has still about 6% of the activity. And the system is telling you that zone 3 and 4 should be avoided as they require individuals to deviate from neutral positions. And that can take excessive time.
I have a question, if I may.
Please, of course, please.
Right. So no, the analytics it looks fantastic. That's a utopian goal for a lot of manufacturers. Everything you've shown has been, I guess, derived from the video, but you're setting up a video camera. But for a lot of our clients, we have a lot of automated lines. So we already have a lot of data points, particularly tech time for individual steps. Is
Yeah.
that something that your solution would work without the need for cameras if we just give you access to a data source where that information is already stored?
Absolutely. So I'm talking about individual station design right now. First of all, there is not much that's human centric here or human focused here. The system will still be able to break down your cycle into meaningful studies, meaningful steps. It will still be able to give you variations and all those good things. But then if you don't even have a video, there are still modules like line balancing. In line balancing, you can rebalance a line, which might have machine auto, machine manual, those kinds of steps. Maybe this is did I understand your question correctly or did I not?
It's the idea here is saying that not using the camera, it's probably not a manual workstation, but here's a production line, say it's a bottle filling line that's
Right,
on there. We're getting a lot of data automatically, so we don't need
right.
cameras, we don't need work instructions.
Sure.
It's
Of
using
course.
the other aspect of it, which is the data analytics, to break down in terms of Kaizen as saying, is there continuous improvement opportunities here by eliminating or focusing on specific steps?
No, our focus at the moment is primarily on discrete industries where there is some sort of either there is a human that is doing the job or there is a robot or some kind of machinery that is processing a discrete things that you can count, right? You're building a glove box in this example. You're building something else. We haven't, in full disclosure, we haven't worked that much apart from 3M, we haven't worked that much in the process industries. At the moment, we haven't pulled in data from machines and tried to do Kaizen on top of that kind of data. Hope
Okay,
that.
and that's fine. And that might be a separate discussion. We're going down the AI. We've already started
Yeah,
an activity here, but I can see here that from AI and machine learning and creating llama, deep learning models,
yeah,
that's a lot of work. We really focus on MES,
yeah,
but we have a massive amount of data. We have analytics. And one of the things that we've always seen is MES solutions continuous improvement is driven by individuals, reliability engineers, quality people inside of a company. The trouble we find with deriving value is that those people quit, they
yeah,
move on. Suddenly there's a vacuum. Data's being captured. Nobody's driving continuous improvement. So if we can actually connect to a system such as AI, what you're doing with Copilot,
yeah,
you almost eliminate the position. You eliminate the disruption
right.
as employees leave because we have your AI driving and looking and saying, hey, you need to be looking on production line two. There's a problem on this shift or with this product, or these are the steps. And maybe there's some synergy.
That makes sense. No, I get it. Yeah, absolutely. Would love to, if you're looking for partners, we'd love to talk and figure out how we might be able to help.
Definitely, we'll talk.
Yeah, yes, sir. Just make a minor change here. I was doing a demo in the morning and made some weird changes. That was station design. You can also do automatic line balancing. So here's an assembly line which has 5 stations where a certain glove box is being built. We did time studies in the tool in station design, and now I'm importing those into this line balancing module. And then essentially I can go in and specify the precedence relationships between those steps. Let me just, so which step requires which step to be completed. For now, I just choose them chronologically that the current step is absolutely needs to be followed. On this screen, the system shows you that there are 5 stations and this is your bottleneck station right now. And because of this bottleneck station or the way, and other bottlenecks, your current line balance ratio is 48%. So you're using 5 operators on 5 stations, 5 operators, but you're using only about 50% of their potential. And what we can try to do is we can say, okay, let's rebalance the line for fewer operators. What if I had 4 operators instead of 5? What would happen then? And that even with 4 operators, I think the parts per hours went down a little bit, but the line gets a lot more balanced. So apparently you do need 5 operators if you want to meet 83 parts per hour. But you can say, okay, what if I need to do Maybe next month you have you have orders to build a lot more and your takt time is going down. What I can say as the system to do is, okay, I need to now produce 120 units a month, an hour, and give me the line balance for that. And it will rebalance the line. It will say, okay, you can do that with by just adding one more station instead of having 5 stations. So you can produce a lot more. And this is your Yamazumi chart, which is the work instructions for each station. You can get a bunch of your Gantt chart or standard work combination table that industrial engineers really like and use for a variety of things. And then again, you can get really rich, really rich Excel sheet templates as well. So a lot of, still folks that work in higher volume, mid-market manufacturers, they are seeing us as TPS in a box. So you're growing your business rapidly and you want to get much more mature processes. You deploy us and you all of a sudden get processes that are a lot more sophisticated. You can train your production staff to have much better documentation, much better planning, and so on and so forth. Just to give one example, this is the before state. There were 5 operators. Now there are 6 operators on this line, and you get a bunch of other kinds of statistics as well. I know we are on time. I'll just give you a sneak peek of a couple of other modules. I do want to make a couple of comments about what we are beginning to do in the job shop space. There are modules like this where we'll build spaghetti diagrams in a cell. As operators are walking around in a cell and doing certain things, we can give you these kinds of spaghetti diagrams of how the operators are walking around those stations. And actually, there's another feature that's shipping actually next week, which is, okay, this is how your cell is organized right now, and this is your walking patterns. We can calculate an alternative layout for your cell that will minimize your walking time. So that's another module. Any questions? Maybe you wanted to say something. Okay. You also have ergonomics in the system. I'll just show you one quick example, and then I'll wrap up or at least make some comments about job shops, what it is that we're working on. The idea in this one is we are following this operator as she is doing a certain material handling task. And then we pass it on, or upload that video into the software. The software automatically extracts joint locations for every joint in her body, and it computes the joint angles. The accuracy of this is the same as wearing actually body-worn sensors. We've been working with University of Waterloo, and that's what they've figured out. But the AI is actually figuring out the risky postures in that process. So this is a risky posture. The risk score is pretty high. 8 to 10 is really high risk. The second risky posture is this one in this video where the operator is basically just dragging this cart with one hand and twisting her body in a weird way. If you go into suggestions, the system can actually give you recommendations on exactly what you need to do to avoid that issue, or what it is that's going wrong. So if you don't have a formal EHS staff, you can still measure your processes, assign risk scores to them, and then arrive at better processes. So in this case, the operator is twisting her lower back in a different way from her upper back, whereas the right way of doing it would be like this. So maybe you want to change the cart in a certain way or something else. But that's the ergonomics piece. We also have purely text-based pieces. Quality planning is about generating PFEMAs out of a text description of a process. We can generate failure modes, we can generate root cause analysis, we can generate what you need to do to improve that process, and so on and so forth. But does that make so big? But that's basically Kaizen Copilot and Ergo Copilot, both of them kind of a really quick overview of those tools. Any thoughts there?
Zeeshan, I'm not a trained engineer, so there might be some engineers on the call who have other comments. But I think what you've just shown us is a whole new level of insight and solving problems much more quickly, especially with root cause analysis, I see, and safety, productivity, and quality. You're going to be the go-to company.
Appreciate it. Yes.
As a young industrial engineer, I think back to when I had the clipboard and the stopwatch and how much time I would have saved if this technology was available and the insights that could have been gained. Just spaghetti diagramming, ergonomics. There's so many use cases, and this is such powerful technology. It truly is exciting. I'm just thinking back within the last 2 years, how the scale and scope of advancements that you've been able to make is truly commendable. Where do you see the next 2 years going?
No, yeah, we are working on a bunch of different things around automation and robotics, around helping our customers. You have $500,000 that you could spend on robotics, but you have to pull in an integrator to bring, you have to bring in an integrator who will help you set up the robots. The challenge is that it's hard. Your people know the best about your processes, and the integrators know the best about the various kinds of robots and the various kinds of things you can do. There's always a communication gap between these two. You may not be able to imagine all the different ways of reorganizing your process to enable better and better automation. And whereas the integrator might not know your process in enough detail to suggest, hey, what if you reorganize it? We are building automation modules, we are building sequencing related modules. If you are have mixed model assembly lines, we want you to be able to, there are imbalances because you are building different kinds of products. We want to help you sequence what you put on the line. So a couple of those modules, but also we are looking into job shops, what job shops need. So one thing that a lot of our product team has spent a lot of time looking into lean and what kind of lean tools, forget about software or AI, what can you do with lean and Toyota production systems in a job shop setting? And one of the key things that we've realized is in job shops, a lot of things just don't apply. You don't have a tag time. You don't really have a consistent line that you want to work with. Oftentimes, what a lot of job shops are wasting time with is they have these departments, and the departments are based on functions. So you have a CNC department, you have something else for department. And one module we are working on right now is, okay, this is your product mix. These are the 1,200 different product numbers that you've built in your entire history of existing as a company. Probably that data exists in your ERP system. And then some data, if you have any data around volume and pricing of those part numbers, what we can do is we can take all that data and recommend prioritization. So if there are certain parts that you build more often than other parts, a lot more often than other parts, and especially if they're part families that really belong to each other. So let's say part A also requires those 10 stations, and part B also requires the same 10 stations, and part D also requires 9 of those 10 stations. This part family is responsible for 50% of your revenues. You don't want to, yes, you need flexibility because you're a job shop, you do whatever parts come your way, customer specs come your way, but 50% of your revenues are coming out of these parts. So what you really want to do is bring in those stations into one cell, maybe it's a U-shaped cell, to optimize the delivery and minimizing the lead time for those part numbers. So what we are working on is taking that data, the part numbers that you build, the volume and the pricing, and then basically giving you cellularization related part families, and then recommending how you can build cells out of that. Because a lot of time in job shops is being wasted, as far as we see, in walking and transportation. That's something that we're working on right away. There are other modules around, okay, you capture a video of a certain process and just directly a little bit more job shop focused, get improvement related recommendations out of the system directly without having to do a time study and those kinds of things. Because again, tag time might not apply to you, to your situation. That's another direction that we're working on, and would love to partner with folks locally if those are the kinds of things that you think make sense for your business. Please reach out.
I have a question with regard to what would be like an ideal customer persona, right? What's the throughput or the type of product that actually best suits solutions such as yours? So you clearly mentioned that something like building an aeroplane may not be suited, but that may be something else. So what does that look like?
Yeah, so typically we are working in automotive, med devices, aero HVAC. We are beginning to look into aerospace as well. We have some early customers there, but for parts that are relatively high volume, we are typically, again, if you look at it from a takt time or a cycle time perspective, we are operating. The ideal products are the ones that you build in about 5-ish minutes or less, and then you can compute the volume from there. So that's how we define roughly high volume, that you're producing probably 100 or hundreds of that part every single day.
So that also means that you need a certain size customer, right?
For Kaizen, again, Kaizen is really simple to deploy. All we need to do is we can create an account for you and you can start accessing tomorrow. There we can sell a single license if you need that. With assembly, yes, the minimum entry point typically is 10 stations that we ask for, but we are somewhat flexible there as well.
I just want.
Sorry.
Go ahead, RD.
The job shop side of things, right? That's an interesting take that you have in terms of realigning, serialization, etc. Because that's an area that I've worked in. I'm not going to take too much time over here, but I would love to connect and talk a little bit more about that, because that's a harder problem to solve than just saying that we recommend the solution.
Yeah, 100%. Makes sense. No, thank you very much. It was a great session. Please reach out. Happy to talk in a lot more detail offline. But yeah, and thank you, Kirk, for having me.
Absolutely. We are over time and such rich discussion. So, Zeeshan, thank you so much again for taking time to speak with us.